the first phase of our code is going to grab the elevated points from our terrain. So if you see, if we zoom in, we have all these elevated points, which are specific points between the counter lines for which we have the specific elevation. And so this will give us, between the counter lines, some points for our point cloud to have more information for our terrain surface. But most of these points are at the base plane. So what we'll want to do first, if we have all of these elevated points in our base plane, like so, for example, something like this, with their specific elevations, what we'll want to do is to grab these points and put them in the respective elevation. And so instead of z being equal to 0, z will be equal to each elevated point. Automatically by doing this operation in Grasshopper. It will read the text in each of the text objects, and then we are going to put that text as the z coordinates for a new set of points that we are going to construct. So first, in order to get the information from that layer, we are going to have to install few plugins for Grasshopper if you don't already have them. So in Rhino, I'm going to write a command which is called package manager. And I'm going to install, I have it already installed, but a plugin that it's called L-Front. Okay, so you search for the plugin, you then install it. And when you're done, you'll have to close Rhino and reopen again to make sure that it has installed it. In the meantime, you might also want to install these other two plugins, which will be used in later exercises, which are called Human and Lunchbox. So again, you can install all these three plugins at one time, then close Rhino and reopen again. In Mac, you might need to do file quit rhinoceros entirely because it might be running in the background even when you close it, and it won't install the plugins completely. So after installing these plugins, we come into Grasshopper again, into our Grasshopper code, and we'll write a command which is called reference by layer. And what this command will allow us is precisely to read the information from a specific layer that we are going to grab. So how can I put or feed this component with the specific layer that I want? I'll add a panel, and I'll write here the name of the layer. So I'll double click and write the name of the layer which has the elevated point, which is this name. Now, when you write the name of the layer, in the end, do not press enter or space, because it will add an extra space to the name of the layer, and then the component, when it's searching the Rhino file for that layer name, it will search with the extra space. And as we don't have any layer with the extra space in the name, it won't be able to grab the information. So when you write the name of the layer, in the end, just click outside of the panel to close it. So now that I have the name of the layer, I'm going to feed the components with the information. So now we grab the information from the layer. And what we'll want to do is to deconstruct each of the text objects in its elements, which will be the base point and the text, basically the information that we'll want. So what we'll do is an operation called deconstruct text, which is also from the LFront plugin. So now, if we connect, it's going to deconstruct all these text objects into several outputs. In this case, the ones we'll want will be the text and the plane, which is basically the base point. But so now we are going to deconstruct the points output into their coordinates in order to then construct new points with the same x and y coordinates, but a different z coordinates. So what we'll do first is going to be deconstruct, which is the operation that allows us to deconstruct a point, and we'll grab the p output in order to deconstruct them. And so it has deconstructed all the base points for these objects into their coordinates. So now we'll construct new points. So we'll do construct point. And we'll grab the same x coordinate and the same y coordinate. But now the z coordinate we'll grab from the deconstructed texts, we'll grab the t output, which will give us the values for the z coordinates of these new points. And so you see that it has automatically, with these few operations, put these elevated points that were most of them in the base plane to their respective elevations. And now I'll just store these points in a point parameter, a simple point parameter. I'll call them elevated points, for example, just to know what's inside this parameter. I'm going to connect to the construct point. And now what I want to do is to store the information permanently in this parameter in order for me to copy the information to another code if I want, without needing the rest of the code or the Rhino file. So after storing in this parameter, if I right-click the parameter and do internalize data, it will remove this connection that we had here, because now the information is stored in this parameter, but it doesn't need the rest of the code. So now here we have the elevated points that we can copy to another code if we want. And so the first phase of our code is complete. We have put the elevated points in their respective heights, in their respective elevations. So now we'll go into the second phase of our code, which will be to grab these curves, these counter lines and these limits, and divide them into several points every each 2 meters, for example, in order to have the most points we'll want to build our terrain with the maximum detail possible. So what I'll do is add some curve parameters here. I can copy and paste them. What I'll do is grab the information from Rhino and store them into these parameters in Grasshopper. So I'll do that by grabbing the information for each layer that we have in Rhino. So what I'll do is minimize Grasshopper, and first I'm going to grab the information from this layer, for example, top curves 2. I select the layer, I right-click the layer and do select objects, and it will select me the objects on that specific layer. In this case, is the curves for every 1 meter. So now I go back to Grasshopper, I right-click the first parameter and do set multiple curves. And what it will do is go into Rhino and read the information that I have selected. So now the information is stored in this parameter. I'm going to rename it to, for example, counter lines 1 meter. And I'll do the same for the rest. So I'm going to minimize Grasshopper. I have these lines selected, so I'm going to click outside of them to deselect. And now I'm going to select this layer, right-click it, and do select objects again. So now it has only selected my master counterlines. So now I go back to Grasshopper. I'm going to store them into this parameter. So right-click, set multiple curves, it goes into Rhino, and now it has stored information here. So I'm going just to rename it to master counterlines. I'll do the same for the rest. So now I'll want to grab these 3D limits. I'm going to click outside to select my counter lines. Now I'm going into my layer 3D limit, which has the limits contained in it. I'm going to right click it, select objects. It has selected my 3D limits. I go back into Grasshopper, right click this parameter and do set multiple curves. And I'll rename it to 3D limits, for example. Terrain 3D limits. And now, finally, I'm going to grab, although we are not going to use in this code, but I'm going to grab this square, this bright green square, which is the limit for the terrain. So I deselected the 3D limits. And now, although it's in a specific layer, I can just select the square, go into Grasshopper, right-click, and as it is one curve, I can do set one curve. And it has put the square in here. I'm going to rename it for square limit, for example, to the square limit. So now I've grabbed from the Rhino file all the information that I wanted. So now what I want to do is to group all 3 of these lines, not the 2D square, because it would then include the 2D square when we would do the terrain, and we don't want to do that. So I'm going to group all of these 3 elements with a merge command. So merge, I'm going to connect. So you'll see the merge command has by default just 2 connections, but when you connect the second one, it adds a third one, and so on. And there's no problem in leaving one of the inputs empty. So now I have all these counter lines. And the first thing that I want to do is to explode the counter lines into their individual segments, because what you'll see in the AutoCAD file is that even when you have a line like this, usually they are composed of several segments, several linear segments like this. So we'll explode the curve into these individual segments in order to then divide each of the segments in its points. So I'm first going to do an explode command. Connect all of these curves. So it has now exploded them into their individual segments. But what you'll see, if I put a panel here just to show you, is that these curves are organized in drawers. So they are grouped by drawers. For example, you see I have a lot of curves in one drawer, and then I have another drawer with another set of curves. So they're a bit messy in their organization inside Grasshopper. And what I'll want for the next operations will be for each of those operations to do to each curve individually. Because if it would do to a set of curves, it might read them in the whole and not divide them as we wanted. So we want each curve to be in their own individual drawer in order for each operation to work for each drawer. So what we'll do is to do a graphed tree operation. And what he'll do is create, as I'll show you, a drawer for each curve. And so each subsequently operation will be done to each drawer individual. So now the first thing that we'll want is to grab the endpoints for these lines, because what you might see is that if we divide a line in several points, it might not, or it might have, for example, until here, every 2 meters, for example, and then we'll have a rest that might be just 1.5, for example. And so it won't grab that final point. So we'll do an operation that will allow us to select that endpoint, which is precisely that, endpoints. And it will give us the start points of the lines and the endpoints. And in this case, we'll just want the output E for the endpoints. But in the meantime, we'll do the operation that we really want, which is to divide all of these lines into several points. So it's an operation called divide length. This one specifically. And this will allow us to divide all these lines with a specific length that you can see here that we want. So before this operation, you might want to save the code just to make sure that it doesn't heavy too much on the computer. So I'm going to connect here to my endpoints, and I'm going to connect here for my divide length. And now I'm only left with adding the length that I want. So I'll right click here and I'll write 2.0. So then if I wanted, I could change this value every 1 decimal. Hit enter. And so it will give me this number slider with the 2.0 number. And if I wanted, I could change this value with 1 decimal. But so now I'm going to connect here to my divide length, and it will divide all these curves every 2 meters and give us a point every 2 meters. And so you'll see we'll have a lot of points with this divide length. And so now what we're left with is with the final steps in our code, which is to make the terrain. So we have our elevated points, we have our endpoints, and finally our curves divided. So I'm merging all of these 3 in with a merge command. So now basically I have my point cloud here. But what might be happening is that we might have some points duplicated in this point cloud, meaning 2 points that are one over the other. And when doing the terrain, it might try to do the terrain twice in that spot, and it might give us an error. So we'll want to remove those duplicate points. So first thing is doing the operation that is the opposite to this graph tree. So if this graph tree puts each curve in its own drawer, we'll want now all of the curves to be in the same drawer in order to read them as a whole, then even for doing our terrain. So we'll do the opposite operation to the graph tree, which is called flatten tree. And as the name indicates, it's going to flatten all of these individual drawers to the same drawer. Now, if I just put a panel here, you'll see that we'll have just one drawer with the zero hierarchy where all of the points are stored. So now, before the next operation, and because the next operation will be heavy on the computer, we'll save the code just to make sure. So I can just come to File and save the document. And the next operation that we'll be doing is called call duplicates. And this operation will allow us precisely to read all of our point clouds and remove any duplicate points that we have. So, as I said, we're going to save the code, and then this will take a while to make. It might take up to 5 minutes, for example. And if you see that your computer isn't able to process this command, you can reopen the code and change this value up here from 2 to 5, for example. And so you'll have less points, but the computer might be able to do this operation. This is an important operation because we saw that it would give us an invalid surface in the end, and it was probably because of some duplicate points that we had in the point cloud. So I'm now going to do this operation and come back when it's done. It took a while, but here we are. It has removed any duplicate points, and now we are sure to have a proper terrain. So now what I'm going to do is precisely that, do our terrain. So we're going to do that through an operation called the law-name mesh, which will precisely process the triangulation between our points. So now I'll connect the points from the col duplicates and do my terrain. And so from our point cloud, we have constructed our terrain surface. Now I'm just going to store this in a mesh parameter, as we did for the elevated points. And I'm going to right-click it and do internalize data to have the information stored in this parameter without needing the rest of the code. So this is this exercise done, but it will lead us into our next exercise, because if we zoom in into our terrain surface, you'll see precisely the triangulation between the points. And so it doesn't give us the more smooth surface, but at least we have all the points in their respective elevations and a preliminary terrain that we are going to call this, that will allow us to then smooth it out if we want, which will be the next exercise.